The next type of example we're going to do here, let me look and see. We had 3 examples, so we're going to have, this will be example 4 for those of you following along with notes. So the next kind of example is going to be something like this that has a problem 2 over 1 plus 9i. So before we just had an I in the denominator. Now we have a complex number. So we have a constant plus an imaginary number. So it's like a plus bi. So for this one, we have to multiply by what's called the conjugate. Okay, it's called a complex conjugate. So the complex conjugate is the exact same thing that we have here, but the sign in front of your I is going to be the opposite. So we have to multiply top and bottom by the complex conjugate. That is this, 1 minus 9i and 1 minus 9i. Okay, so what happens is we're still distributing on top, but now on the bottom we are double distributing. So we're going to distribute the 2 here, and we will have 2 times 1 is 2. 2 times negative 9i is negative 18i. On bottom, we're going to have 1 times 1 is 1. That's difficult, right? 1 times negative I is negative I. And then we have to distribute our 9i here. So 9i distributes to 1 and gives you a positive 9i. And 9i distributes to negative 9i, and you have negative 81i squared. So here's what's nice about complex conjugates. Not only does it get rid of your I in the denominator in the end, but part of that is because your 2 middle terms will cancel every time. If they don't, you have done something incorrectly. So if I simplify here, I squared is like multiplying by negative 1, yes? So I have 2 minus 18i over 1, and negative 81 times negative 1 is positive 81. So I have 2 minus 18i over 82. So the math part is done, but now we have to reduce. So because all 3 of our numbers here are divisible by 2, this will become 1 minus 9i over 41. So remember our goal, we start with an I in the denominator, we end without 1. That's the point.